Hi, Math 2 Enhanced. Let's look at some word problems on part 2. So Jack's parents invested in this college fund. So on his 18th birthday, so that's the time, that's the amount of years that it went by, it has this amount of money in it. So that's its A of t. That's what it's equal to in the end. They were able to invest in this rate, which as a decimal is 0.055. And it's compounded semi-annually, which is twice a year. So that means in this problem, my n is 2. So as far as which equation I'm going to use the equation that has my n in it for compounding. So the amount I ended up with, 42,550, is equal to my original amount, which I'm trying to find, times 1 plus my rate, which is 0.055, over the number of times it's compounded, which is twice a year, to the number of times it's compounded, 2 times the amount of years, so it's really to the 36th power. So I'm going to go ahead and calculate, if I can grab my highlighter, I'm going to calculate I don't know why it's, I'm going to calculate all of this. I'm just going to get a number for it. So I'm going to put all of that into my calculator, and when I do, when I do, I have my $42,550 equals P times, and this is 2.6554975. Could I not carry so many decimals? For sure, but I just have them all there, so I'm going to leave them all there. So I'm going to divide both sides by that number. That's going to get rid of it, and I'm going to just have my principal. So I have to divide this side by that number. And when I do that, I get $16,004.72 for my P. So let's take a look at problems where I have to utilize my natural log. It says, how long does it take for a deposit, so that's my initial amount, to double? So I want it to be $2,000 at 8%, so it's 0.08, compounded continuously. So this is an E problem. So if I look at my formulas, I'm going to use the second and third one from the bottom of the list. They're really the same problem. It's the amount I want, the amount I finish with, equals my original amount, times E to my rate times my time. So what I don't know in this problem is time. I need to isolate my E term first. So I'm going to divide both sides by 1,000. I'm not surprised to get a 2 over here because I wanted my initial amount to double. So I'm not as surprised I get a 2. That's doubling. Equals E to the 0.0 t power. So since it is an E, I'm going to do the natural log of both sides. That's going to allow me, with the power rule, to drop my 0.08 t in front. So I get natural log of 2 equals 0.08 t times natural log of E. And my natural log of E cancels to 1. And I'm going to divide both sides by 0.08. And when I do that on my calculator, I get approximately 8.66 years. So 8 years and 66% of the next year. At what interest rate, so I'm going to be looking for my rate, would a deposit of $30,000 grow to $2,540,689 in 40 years with continuous compounding? So it's going to be an E1. So again, I'm using that second or third to the bottom of the list on the previous page. So my final amount is the $2,540,689. I begin with $30,000. E to the rate, which I don't know, times my time, which is 40. So we're going to start by dividing both sides by 30,000 to isolate my E term. And then when I do that, I'm now going to want to take natural log of both sides. That allows me, so I've got natural log of the left side, so it's natural log of the whole thing. My 2,540,000 number divided by my 30,000 number, it's natural log of the whole thing, equals natural log of E to, I'm going to write it as 40 times R. But by the power rule, I'm allowed to move the 40R down in front. And I know natural log of E is 1. So I really get the natural log of my left side equal to 40R. So I'm going to divide both sides by 40. Sorry, I had to write in the last problem. And I'm going to just stick all that in my calculator. So I'm going to do, if you're on a classroom calculator, the 2,540,689 divided by 30,000, hit equals, then touch natural log, then divide by 40 and hit equals. If you're on the navy blue calculator, you could probably type it as a sentence. You should be getting 0.11, which makes sense because that's really 11% interest. So now this boulder problem matches the boulder problem in our notes completely, like line for line, except I believe this number is different. I think in the example it was 10, now it's 15. So it says a boulder originally has this mass, and so that's the original mass. The 15 is the amount of time that have elapsed. It's continuously, so I know it's an E equation, and it's going to be half its original size, so that's 1,500 kilograms. At what rate? So I'm looking for my R. So I'm going to use, again, that second and third equation from the bottom. Let's put in our numbers. So my mass decays to half its original size, E to the R times my T, which is 15. I'm going to divide both sides by 3,000. I'm not really surprised to get a 0.5 on the left because it is decaying to, not really decay, but dissolving to about half its original size, equals E to the 15R. So I'm going to do natural log of both sides. And when I do that, it allows me to bring my 15R down in front. So I get natural log of 0.5 equals 15R times natural log of E. Natural log of E is just 1. They're inverses of each other. And now I can divide both sides by 15. When I divide by 15 and you put it in your calculator, I get a negative answer. I'm not surprised by a negative answer because this rock is dissolving. It makes sense that my rate is something negative because it's decreasing in size. This means that it's decreasing in size at a rate of 4.6%. Because it's negative, it's decreasing. Nigeria is the deforestation occurs at this rate. So this problem, by the way, is also identical to a problem in the notes. I just changed the 50% to 60%, just so you know. So you can locate this problem there. Assuming the amount of forest remaining is determined by this function, f equals f sub 0 e to the negative 0.052t, where f sub 0 is the present amount of forest land. It's the number of acres you originally have. You want to know when you're only going to have 60% left. So if I want to know when I have 60% of something left, I'm going to take my original amount and I'm going to multiply it by 60%. That's going to tell me when I have 60% left. Like if I had 10 acres, I'm looking for when I have 6 acres left, 60% left. So it's 0.6 times my original amount equals e to this negative 0.052t. So the first thing I'm going to do is divide both sides by my original amount. Again, I'm not surprised to see a 0.6 here because I am calculating the amount of time it takes it to be 60% of its original time. It makes sense that I have a 0.6 there for 60%. So this is an E problem. We're going to do natural log of both sides. When I do that, I'm going to drop my exponent down in front. I get natural log of 0.6 equals negative 0.052 t times natural log of e. Natural log of e is 1. And then I'm going to divide by, sorry, I'm writing into the next problem. I'm going to divide both sides by that negative 0.052 t, or 52. And then that's going to leave me with my t equals, and when I do that division, I should get 9.8 years. You shouldn't get negative answer there because you have a negative in your denominator. So in the next problem, this is talking about El Salvador, and it says in 20 years, only 53% of the present forest will remain. So it says use this model to determine the annual rate of deforestation. So the 20 years is my time. So again, in this problem, I don't know my original amount. It didn't tell me that there were 100 acres or 1,000 acres or 1,500 acres or 1,000,000 acres. Like, I don't know how many acres of forest we're talking about. That's my F's of 0. But I do know that I want to find out when 53% of it remains. So that's 0.53 times the original amount equals the original amount, E, to my rate, I don't know, times my time, which is 20 years. So on this one, I'm going to divide both sides by F's of 0, and it cancels. And now I'm going to take natural log of both sides and drop my 20R down in front. So I get natural log of 0.53 equals 20R, natural log of E. The natural log is canceling to 1. I'm now going to divide both sides by 20. And I'm going to get R equals negative 0.032. I'm not surprised that I get a negative rate. This forest, it's deforestation. The amount of forest land is getting smaller. And so this means that it's decreasing by 32%, or 3.2%. I'm sorry, you only move it 2 places. 3.2% each year. So let's take a look at this population question. It says the population of the world doubled. It got twice as big from 1950 to 1987, going from 2.5 billion to 5 billion people. Using this exponential model, find the annual growth rate for that period. So I'm going to do this problem in billions. I'm going to say that 5 billion people is the amount I ended with, and I began with 2 billion people. If you want to include all the zeros, feel free, but I'm just going to say my problem's in billions, because technically I don't even need to write those numbers. I'll talk about it on the next line. E to the rate I don't know, and the amount of time that elapsed from 1950 to 1987 looks like, 37 years? So when I divide both sides by 2.5, or when I divide 5 billion by 2.5 billion, depending on how you wrote it, I'm always going to get a 2. It's asking about how long it took the world's population to double. So no matter what numbers I had for my initial population and final population, I'm always going to get 2 because the population doubled. So I'm not really surprised by that. Equals E to the 37R. So I'm going to do natural log of both sides since I have an E. And I'm going to drop that 37R down in front. So natural log of 2 equals 37R natural log times E, which is 1. I'm going to divide both sides by 37. And when I do natural log of 2 divided by 37, I get 0.01873. And that would mean that the world is growing at a rate of 1.873% each year. Let's take a look at page 2. So the first 2 problems are our favorites. They're half-life problems. So step 1, I'm going to use my half-life to calculate my decay constant. I'm not even reading the rest of it. I'm just seeing that my half-life is 12 days. I'm using my last equation on my notes, front of my notes page. So my amount that I have, whatever my amount is, I want it to decay to half. So let's say my original amount was 2, it's decayed to 1, and that happened in 12 days. That's E to the negative K times 12. I'm going to divide both sides by my 2, and I'm going to get a 1/2, or 0.5 equals E to the negative 12K. I'm not surprised to have a 1/2 there. Some of you might have started with a 1/2 there. I want half the amount to remain. So 1/2 is equal to my E to the negative 12K. So I'm going to do natural log of both sides. And when I do that, I'm going to drop my negative 12K down in front. So natural log of 1/2 equals negative 12K times natural log of E. You and I both know that the natural log of E cancels to 1. And so it looks like I'm going to divide both sides by my negative 12. And my K is equal to 0.05776. By the way, if you're coming to this video having already done these problems and you got a negative K, negative 0.05776, that's fine. That means that you used a positive rate formula. So in this next step, you're going to be substituting a negative answer. And so on this next step, when we calculate 40 grams to go down to 14, then I'm using that last equation. I'm using that last equation on our list of equations. So I want to find out how long it takes 40 grams to become 14. E. So now I'm putting in, it's negative in my formula, and I'm putting in this positive K I just got. But if you use the positive formula, you're plugging in a negative K that you just got. Either way, both of us are getting a negative decay constant in this problem. I'm going to divide both sides by 40 to isolate my E. I get 14 divided by 40 equals E to the negative 0.05776 T. I'm going to take the natural log of both sides in order to move my exponent down in front. So I have natural log of 14 over 40 equals negative 0.05776 T, natural log of E, which cancels to 1. Lastly, I'm going to divide by negative 0.05776. And when we do that on our calculators, we should get T is, I ran out of room here, sorry. My T equals 18.17 years. So let's take a look at the next problem. My half-life is 1,500 years. So my step one, I'm going to use the 1,500 to find out how long until I have half my amount. So I'm going to just jump in with the 1/2 equals E to the negative K times 1,500. This was my example problem, if I'm not mistaken. So you could check back there to see how that one was done. But I have my natural log of my 1/2 equals negative 1,500K times natural log of E, which cancels to 1. I'm going to divide both sides by that 1,500, negative 1,500. And I get K, which is a long number, 0.000462098. Notice it's not negative. That's because I'm using the formula with a negative in it. If you were using the formula with a positive K, you just got a negative answer. But both of us then substitute it into our formula on the next page. So I want to know how long it takes 20 grams to go to 14. So 14 and 20. E, and I'm going to insert it into the formula that has a negative. T. So I'm going to divide both sides by 20 to isolate my E. And then I'm going to take the natural log of both sides. So I get natural log of 14 over 20 equals, I'm going to move my exponent down in front of the natural log. Sorry, natural log of E. Natural log of E cancels to 1. Then I'm going to divide by my decay constant. When I do that, my numerator divided by my denominator, I believe I get 771.86 years. So how about problems that we use log to solve? These would be problems that don't have an E in them. So let's check out this first one. You deposit I don't know what that is. Sorry, one second. You deposit $2,500 into an account, and it's compounded monthly, so my N is 12. In how many years, I'm looking for T, will you double, so 5,000, at a rate of 0.045? So I want to know how long it's taking 2,500 to become 5,000. And because it's got an N in it, I'm using the N formula. 1 plus 0.045 over my N, which is 12, to the N times T, so 12 times T exponent. So I'm going to divide both sides by this 2,500. I'm not surprised to get a 2 on the left side. I am trying to figure out how long it takes this rate to double my money. And since there is no E here, I'm going to do log of both sides. The log allows me to drop my 12t down in front, which is really the whole point of all of this. Okay, so this here is really 12 times t times log of 1 plus 0.04 divided by 12, 0.045 divided by 12. And the log of 1 plus 0.045 divided by 12 is just a number. So when I want to move numbers away from my variables, I just divide by them. So I'm going to divide by 12, and I'm going to divide by a log of 1 plus 0.045 divided by 12. And when I do that, I have to divide the other side by them. So that's 12, and then log of 1 plus 0.045 divided by 12. And this is one where you have to be careful how you put it in your calculator. So I'm going to do log of 2, divide by 12, divide by, because it's in the denominator, log of 1 plus 0.05 divided by 12. And when I do that, I should get 15.43 years. If Joey invested $5,000 at 5% yearly interest compounded quarterly, which is 4 times, how much would it be worth after 5 years? So this isn't really a problem from part 2. It's really a part 1 problem. So I want to figure out how much what amount he's going to have if he invests $5,000 at a rate of 0.05 compounded 4 times a year. And to the exponent of the 4 times a year it's compounded times the 5 years it sits in there. So my exponent's really 20. So I would, of course, do my parentheses first. 1 plus 0.05 divided by 4, hit your equals to the 20th power, and then multiply by 5,000. The amount of money he's going to have after 5 years. Sorry, I need to look at my paper. It looks like it was $6,410.19. So what makes it a part 2 problem? Well, that's B. It wants to know when the investment, when. So I'm going to be looking for the time for this to be $10,000. So I'm going to see when my initial 5,000 times my rate, which is 1 plus 0.05, divided by the 4 times a year it's compounded to the 4 times t power. I'm going to see when that's equal to 10,000. So I need to isolate my base, my parentheses. I'm going to divide both sides by 5,000. When I get done, I get 2 equals my 1 plus 0.05 divided by 4 to the 4t. So now I'm going to take the log of both sides. That allows me to bring the 4t down in front. So I get log of 2 equals 4t log of 1 plus 0.05 over 4. Now this is just like number 10. I have 2 things I'm multiplying by t, so I need to divide both things over. I need to divide both sides by the 4, and I need to divide both sides by log of 1 plus 0.05 divided by 4. Log, sorry if it's hard to read, I apologize. Now my 4's cancel, now my logs cancel. I get t equals, and again on my calculator when I type it in, I would do log of 2 equals, divide by 4, divide by log of the 1 plus 0.05 divided by 4. If the calculator is the issue for you, please stop by and see me. I'm sure it'll be an easy fix when I see how you're keying it in. But I should be getting 13.95 years. So now let's take a look at number 12. You deposit $1,000. Oh, I guess there's 2 problems. I'm sorry. This is utilizing my first PDF, which there is not enough room for number 12. I am really, really sorry. I think the printout I gave in class, I moved things around to make more room for 12. Sorry about that. You deposit $1,000 in investment compounded monthly, which is 12 times. In how many years? I'm looking for T. Will you double your investment? So I'm going to get 2,000 at a rate of 0.055. So I'm using that second equation in our list. I want to know when it's going to be 2,000 after I've deposited 1,000. times 1 plus 0.055 compounded monthly to the 12t. So I'm looking for t here. So first going to divide both sides by 1,000. I'm going to get 2 equals 1 plus 0.055 divided by 12 to the 12t. And now I'm going to take the log of both sides because the log allows me to move that 12t down in front. So I have log of 2 equals 12t log of 1 plus 0.055 over 12. And again, I've got to get the 12 moved away from the t, so we're going to divide both sides by 12. I got to get that log moved away, so we're going to divide both sides by log. And let me write that over here too. And then the 12s cancel, the logs cancel, and I just have my t. And if you're having difficulty putting this into your calculator and getting the correct answer, please stop by and see me with your calculator. But I'm getting 12.63 years for that answer. So for number 13, this is the equation that models the population at this school. So currently, I know there's 1,200 kids because that is my initial population spot. That's how many kids there were in the beginning. The high school is increasing. I know that because I see the 1.017 in parentheses. It's greater than 1, so I know it's increasing. In fact, I know it's increasing by 17%. Or I'm sorry, 1.7%. You only get to move it 2 places, 1.7%. What will the population be in 2030? So that's in 10 years. Again, that's really a part 1 question. It's not a part 2 question. So I'm going to simply do P of 10 equals 1,200, 1.017 to the 10th power. If you plug all that into your calculator correctly, I believe you get 1,420.33 students. Now, when will the population be 1420? So this is a part 2 question. I want to know when that population is going to be 1420. So the first thing I'm going to do is divide over that initial population of 1,200. And then I'm going to take the log of both sides. Since there's no e, this is a log problem, and I'm going to drop that t down in front. So log of 1420 divided by 1,200 is equal to t times the log of 1.017. That's just a number, so I'm going to divide by log of 1.017 on both sides. Remember here, the logs cannot cancel. So I'm going to do the numerator equals, get an answer, then I'm going to divide by the denominator. If you put that into your calculators correctly, you should get 9.98 years, which makes some sense because really C and D were kind of the same question. I asked what would be the population in 10 years, and you get 1420.33, which actually, when you're talking about people, it should just be 1420. We shouldn't have the 0.33. You can't have 0.33 as a person, plus it said nearest whole person. I actually wrote that. So then, and then the very next question, I asked, when will the population be 1420? I'm not surprised it's just shy of 10, because really when I put a 10 in, I got the 0.33. So it makes sense that the year is something just shy of 10. That would give me the 1,420 exactly. Okay, I hope this was a helpful video, and I will see you in class. Thank you.